Okay, in this video we're going to be looking at sketching the reciprocal function, and this is what we mean by the reciprocal function. So we've got 1 divided by x, so our variable is x, and you might already be able to spot a problem that this might create. What if we put x is equal to 0? We're just going to have 1 divided by 0, and that's not defined. We don't really want to do that. So you might already be able to see we're going to have a little bit of a problem here for a particular number. But let's go ahead and draw the axes. We want to try and visualize what this function looks like. So we have the x-axis and the y-axis up here. So to sketch this, we're going to look what happens when we put x being a very large number and a very small number and a very large negative number, just to get a feel for the shape of the graph. So if we say x goes to positive infinity, this is kind of notation to say as we take x to be a very big number, so we're pushing x on this axis to the right. What's y going to happen? What's going to happen to y? We're going to have 1 divided by a very large number, which means we're going to get a very small number. So if x tends to infinity, then y tends to 0, right? So as x gets bigger and bigger and bigger, y is going to go to 0, which means that as on the graph, as x goes to the right, y is going to go down towards the x-axis. Now if we take x the other way, if we take x towards 0, so if you're going this way and we're approaching the origin, then we're going to have 1 divided by a very small number, and it's going to keep getting smaller and smaller, which means y is going to get bigger and bigger. So then y is going to tend towards positive infinity. So it's kind of have the opposite effect. So as x goes towards the origin, y is going to go upwards like this. Now let's try negative values of x. So if x goes to negative infinity, if we push x towards the left-hand side very far, we're going to have 1 divided by a negative very large number. So we can just take out the negative to the front, and then we're going to have minus 1 over a very large number, which is negative of a very small number. So we're actually going to get that then y also goes to 0, but it approaches it from the left-hand side. Right, so we're going to get, as x goes to the left, y is going to go down, it's going to come from the bottom side because it's going to be negative, so it's going to go up towards the x-axis here. So I'm just going to make a little change here. I'm going to write a plus here to mean x is coming from the right. So it's always going to be a positive number, and it's going to go towards 0 from the positive direction. So we're going to get y to be a positive number. And now we're going to look at the case when x goes to 0, but from the negative side, so it's going to come in from the left-hand side, which means that we're dividing by a very small number and it's negative, which means it's going to create a very big number, but this time it's going to create a very large negative number. So in this case, we get y tends to minus infinity. And now we've got all the information we need really to get an idea of what this function looks like. So in the limits, we know that when x is very large and positive, y is going to be very small. And when x is very small and positive, y is going to be very large and positive, just from these two lines. Now these two lines tell us that as x goes to the left-hand side, as it gets very large and negative, y is going to go towards 0 from the left-hand side. So we're going to get something looking like this in the corner. And then finally, when x goes to 0 from the left-hand side, y is going to go to negative infinity, so it's going to go down here. And now we need to kind of connect the dots, but in a continuous way. And we see that if x is always positive, then y is always going to be positive. So these two corners are going to connect. And similarly, if it's negative, then y is also negative. So what we actually end up seeing is a curve looking a bit like this. Curving down towards, so as x gets bigger, y gets smaller. And similarly, as x tends to 0, y goes to infinity. So it's a very weird function because x and y kind of balance each other out in terms of size. If x is really small, then y is really big, and if x is really big, then y is really small. And as I was mentioning before, we see that we haven't got this function defined for when x is equal to 0. It's the only place where it isn't defined. And this place, this axis, I'm just going to, let me just draw a dashed line here, right next to it in blue. This is called an asymptote. Asymptote, P is silent. And this essentially is a name for a curve that approaches this line but never touches it. So it keeps getting closer and closer and closer As you make x smaller, y is going to get bigger and bigger, and the curve is going to approach this line, but it's never going to reach it. And then similarly, if you kind of flip it on its head, we also have y equals 0 as an asymptote, because this curve tends to y equals 0, but it never reaches it. So in this case, the asymptotes are x equals 0 and y equals 0. And it's a quite weird function because you don't really see this behavior in normal polynomials like quadratics or cubics. It's only when you're dividing by the variable, this is when we get these problems. So now we're going to generalize this one step further and see what happens if we put a constant on top. So let me just clear out some space first. Okay, so now we're interested in the function y equals k over x, where k is just a constant, it's a number. And what we can do is we can split two cases depending on the sign of k. So if k is greater than 0 and k is less than 0, then we're going to get two different types of behavior. And we can sketch what these look like. So I'm just going to draw two graphs out here, and we're going to have a look to see what they look like. So x and y axes. Now if k is positive, we're going to get something very similar to when k was 1, when we just had 1 divided by x. We're going to have something looking like this, where it comes down in the first quadrant and the third quadrant. So when x is positive, then y is always positive, and when x is negative, y is also negative. But if we put k equals a negative number up here, then this is going to flip it on its head. We're going to have when x is positive, y is going to be negative, and when x is negative, y is going to be positive. So what we end up seeing is kind of like a reflection in the x-axis. This curve up here goes down here, and this curve goes up here. So we get something looking like this, which is quite weird. And the last point I want to make is that as you make k bigger and bigger, this just has the effect of pushing the curves further away from the origin. So these two curves get further away as k gets bigger. So as an example, if we had k being bigger than the original k I've drawn here, we might have something looking like this, where blue represents k being larger. And similarly, if k is negative, then if you make k even more negative, it's just going to push it further away from the origin. So we're going to get something like this. So it's very symmetrical in nature. And that's essentially everything you need to know about sketching the reciprocal function.